Welcome back to another one of my applications of differentiation videos. This will be focused on Rolle's theorem, or I think that's how you pronounce it. But yeah, let's get right into it. So, Rolle's theorem, basically, like the mean value theorem, has to satisfy three conditions. The three conditions have to be met for Rolle's theorem to apply, and that would be that the function has to be continuous on the closed interval of a to b. The function has to be differentiable on the open interval of a to b, and function of a, the function of point A, equals the function of point B, which is basically saying the y values equal. And if these three are met, then the derivative of f of c equals 0, and then you use that to find the point at which the slope of the tangent line, that's where the slope of the tangent line at that point is equal to the slope going across of the secant line, which is, so you have a function comes up like that. That would be a, that would be b, they go like that. They're the same height, therefore f of a equals f of b. And that secant line, these are the 2 points, that secant line that passes through them. We look for a point, C, somewhere around here, where the slope at this point is parallel to this. Okay, so that's what we're looking for. Anyway, so let's, example 1. We have a function which equals 2x squared plus 2x within the domain of -1 and 0. I'll try and use a different pen. Okay, so this is our A and this is our B. We're saying that well, this graph here, it looks something like, I'll draw it up first. It looks something like, there's one point at 0, and there's another point at -1. Comes down like this, and then it scoots up like that. Okay, so where this is A and this is B, and what we're trying to find, this is the x-axis is the slope from point A to B, and we're trying to find a value here in between. It should be about -0.5, where the slope of that C value is equal to the slope going through the 2 points. That's -1 and that's 0, and it'll be a roughly -0.5. Anyway, so in this case, yes, if the conditions are met. Now we need to find if the conditions are met. How can I forget? So is it continuous between the two intervals? Yes, there's no disconnection or anything. Is it differentiable? Yes, because there's no sharp points on the whole curve. Therefore, the next condition we need to meet is this one, which is the function of A equals the function of B. Okay, so we find that out by, we use A, we say A is equal to -1, and therefore if we insert that into the function, f of A equals -1, it equals 0, which makes sense because the y value is 0 because it's on the x-axis, and therefore the other one should be, but I drew that up because I knew what it looked like. In this case, we don't know what it looks like, so we're figuring it out. And b equals 0. Therefore, the function of b, if we insert b into the function, we end up getting a value of 0. Therefore, does f(a) equal f of b? Well, 0 equals 0, therefore tick, that's the condition met. And once that condition is met, we're now saying that the derivative of c of f of c equals 0. When this condition is met and those other two conditions are met, this is what we do. Okay. Now, what do we do with this? Well, basically, we got to find a function of c, and the function of c is the same as the original function, except we just replace all the x values with the c all the x's with c's. So you have 2c squared plus 2c. Okay, and now we're going to derive that, and we get derivative equals 4c plus 2. Okay, and now we said when those conditions are met, which they are, which proves that we use Rolle's theorem, which is the derivative of f of c equals 0. We let this equal to 0, and that equals 4c plus 2. Subtract 2 from both sides, we get negative 2 equals 4c. Divide 4 from both sides, and we end up getting c equals negative 2 on 4, which is the same as c equals negative a half, which is the same as negative 0.5. And that means at that point, c equals negative a half. The slope at that point is equal to the slope going through the 2 points, which is correct. And if you were asked to find the coordinates of this, you would just sub this. If you wanted to find the y coordinate, you would just sub this back into the function, and it would give you the y coordinate, because this is essentially the x coordinate. But anyway, so if that helped, hope it did. Thanks for watching, and hope you have a good day.